Hey guys, welcome to today's video. The topic of today's video is normal force. So what is a normal force? Essentially, it's a rather odd concept, but once it's understood, it's fairly simple. So what it basically means is, for example, if this is a table and there's a box on that table. Now, whatever the weight of say it's 5 kilograms, whatever the weight of that box is, it has weight downwards because of gravity, right? So this is the weight. So whatever the weight is, that is not the only force that is acting on this whole situation. There's an upward force called the normal force, which is shown as F sub n. Now, what this normal force does is that it makes sure that the box doesn't move. It doesn't go all the way down or it doesn't go up. So it kind of counteracts the weight. So it counteracts the force applied by this box. So this box doesn't move. So for today, we're only going to look at normal force in the y-axis. So just remember this. We're looking at this in the y-axis. We don't care about the x-axis right now. We're caring about the y-axis. We're only looking at one dimension. So let's see now. If we calculate the normal force itself, we know that weight, the formula for weight, equals mg, right? Mass times gravity. And the value for gravity, acceleration due to gravity, is 9.8. So let's calculate the weight applied over here in force, in terms of force. It will be weight equals mass, which is 5 kilograms, multiplied by 9.8. Usually it's negative 9.8, but for the sake of this problem, we only need the force, and forces, we don't care about negative or positive here. So we're going to get 49 newtons, and this is going to be newtons since it's a force. So in order for this box not to move, the force applied in this whole scenario needs to be 0 newtons. So how much will the normal force be in order to counteract the weight? Since the weight is 49, how much must the normal force be in order to counteract this weight? 49 newtons, right? Since 49 and 49 will cancel each other out. But is it possible to increase or decrease the normal force? All right, so on now whether we can increase or decrease the normal force. Now let's look at that. So for example, we have a table and a box of 20 kilograms. That's the weight of the box. Now, the force due to the weight will equal to 196, since weight equals mg, mass times gravity. This is the mass, gravity. Now let's apply a force to this. So if we apply a force, that will be downwards. Now, say I'm pushing on that box. We're going to have an applied force of equal to, let's say, 200 newtons. Now, initially I said we're looking at this in the y direction because all the forces are up or down. So let's add all the forces in the y direction. Now, keep in mind that all the forces in the y direction must equal to 0. And if that's not the case, the box will not stay on the surface. It'll either go up or down, depending. So we have now it will always have an upward force of obviously a upward normal force. We just need to find what the normal force is after applying that much pressure. If we didn't apply any pressure, the normal force would be equal to this, since it has to equal to 0, right? Since the whole thing needs to equal to 0. But now we're applying force. Now let's see what the normal force is. So since weight is going down, it's going to be a negative. Applied force is also down, so another negative applied force. And normal force is going up, so normal force add, right? All of this needs to equal to 0. So if negative weight minus the applied force plus the normal force equals 0, we need to find the normal force. So that means the normal force equals applied force plus weight, right? So let's plug that in now. So our normal force will equal to applied force, 200 newtons, plus 196 weight, which is then going to equal 396 newtons of force. So that makes sense, right? Because if you push on the box, it'll be more force will be on the surface, therefore it'll have to push even more. So it's increasing the normal force. Now, can we decrease the normal force? Let's see that. Another table, 20 kilogram box. Now, if it has a tension force, which means, say you're pulling it up or pulling up by a rope or whatever, if it has a tension force, the tension force is going to face upwards, right? And the weight is always going to be down, equals to 196, and there will be a normal force. We don't know that yet, right? And we have a tension force, which equals to, say, again, it equals to 50. Now, again, we use this equation. All add up the sum of all our forces in the y-axis will equal to a positive tension, negative weight, and positive normal force equals 0. So let's see that. Tension minus weight plus normal force equals 0. So normal force equals to, this adds over here, the weight minus the tension. Let's plug that in. Equals to 196 minus 50, which then will equal to newtons, 146 newtons, right? So that makes sense, because if we pull the box, we're making it lighter, therefore lesser force is needed to push up on that box. Now, say what if our what if our tension in this problem wasn't 50, it was 200, let's say that, then what would it be? So again, same equation, just with normal force equals weight, 196, minus the tension, 200. Normal force equals negative 4 newtons. And what does this mean? Negative newtons. And why? Since we add all this up and we're getting a negative answer, so that means all the forces in the y-axis will not equal 0. What does that mean? Well, that just means that the box won't be stationary or won't stay on the surface. It'll go up. That's what a negative normal force means. So that's just it. That's a whole concept of a normal force, right? If something is on a surface, so this paper is on a surface, it's pushing down because of the weight and gravity, but the table is also pushing up because of the weight and gravity. That's all. And this is how to do it mathematically. Thank you for watching our video. If you have any questions, you can email us on our email address. It will be on our YouTube channel and at the end of this video. I will put a big picture of all of these calculations at the end of this video, if that helps. Thank you.